All right, welcome. So this is the second video for the nonlinear optimization. And here we're going to look at a Markowitz problem. And of course, hopefully you guys remember from one of your classes, but Markowitz is a very famous finance professor. He won the Nobel Prize for this, but it was Markowitz who realized, the efficient frontier, right? The efficient frontier between return and risk. And so that's what this model is going to do for us. We're going to be able to say, look, maximize our return subject to some minimum amount of risk that we want. Or we can flip it around and, what's the minimum risk for this level of return? So this is that same data that we've been using, right? Foreign stocks, international bonds, so on and so forth. Oh, and once again, I'm going to show you a much easier way to do this problem than what's done in your book. I refer to page 384, right dab smack in the middle. It says the complete Markowitz model involves 12 variables and 8 constraints. No, it doesn't. I'm going to show you a much easier way to do this. Okay. So as always, we're going to get started with our choice variables. I mean, that's not going to change. Okay. And again, I'm just going to put in placeholders here. So copy this across. All right. And then the same thing is happening, right? So, if we invest so much in each of these securities, what will our return be in year 1, year 2, year 3, year 4, year 5? All right. And as your book points out, we're going to say that these are all equally likely. Okay. So as before, what is return 1? Oops, that didn't go well. So I need return 1 to return 5. Okay, so return, if the returns from year 1 happen, and we invest 20% in everything, then we're going to get, okay, I can do this. There we go. We'd get a 30% return. So let me anchor my choice variables, and I'm going to copy this down. All right. Now, we're assuming that each year is equally likely, okay? So let me zoom out a little bit for you. So the idea here then is what is my expected return? So remember, I'm trying to maximize next year's return. Right now, there's a 20% chance that these returns could occur. 20% chance these returns could occur. So on and so forth. So what is my expected return if I invest these proportions in these assets? So my expected return, I'm just going to do expected return, right, is just the average of all of these returns, right? Now the reason for that is because we're going to assume that these are all equally likely. All right, so I'm just going to take the average. Okay, voila. Okay, so there's my expected return. Now I need to calculate my standard deviation, right? So again, the same thing is going to apply. I need a column of squared deviations, right? So here would be the return from scenario 1 minus my expected return, and then I square that, okay? And let me anchor the expected return, okay? So, oops. So here are all of my squared deviations for my various returns. Now remember, if I sum those squared deviations and then divide by the number of observations, right, that's going to give me my variance, all right? So that's what I'm looking for. That would be the variance of my portfolio. So here, is my variance. So the easiest way to do that is sum of the squared deviations. Okay. And then let me show you a little trick. Then divide and then use the count function. So count. Okay. And then count how many observations. That's all the count function does. I don't know if you can see this on my screen, but this function is returning a value of 5 because the count function just says, well, count how many items are in this box of cells, right? Now the reason I'm suggesting you use the count function, because then you don't have to worry about how many potential returns you have, right? I mean, what if you're doing this over like 100 stocks, right? You don't want to be counting, how many stocks do I have in my little universe and count each stock just, by hand. You just want to do it by the count function. That's why I'm suggesting that. It just makes your life easier. Okay, so here we go. So I've got my expected return, right, for the next year, assuming that these returns are equally likely. And then based off of that, I calculated the variance of my portfolio. All right. So what we do in this first one, they wanted the minimum return to be 10% or greater. So this expected return is now going to become one of my constraints. So this is greater than or equal to 10. Okay. So my point is, here are my choice variables. These choice variables will determine my returns, right? I don't need all the variables that your author is talking about, right? Because I've got these, and then your author's putting in R1 through R5, and then your author thinks this has got to be, I don't even know what some of his choice variables are. Okay, you don't need them, right? But again, the link here is that these R's are linked to both the expected return, which I'm going to need in just a moment when I maximize my return, subject to keeping my variance at a minimum, right? Or here, in this case, they're tied to my variance formula through my squared deviations. Okay, so what this problem calls for is I want to minimize the variance of my portfolio subject to getting at least 10%, all right? And then I do have one more constraint, and I guess I'll call that the sum. So, right, this is that the sum of my choice variables has to equal 1. So, let's do that. I'm just going to go to sum. Okay, so that sum has to equal 1. All right, and my friends, you're done. All right, this is it. We are now ready to run this model. So I'm going to go into Data, Solver. Okay, so again, I want to minimize my variance subject to getting at least 10% return. All right, so I want this cell to be minimized by changing these cells subject to this has to be greater than or equal to this, and that has to equal 1. Non-negativity, I got my linear, solve. Hit OK, and there you go. So if I go to page 385 and look at the book, sure enough, these are the answers that your author got. Despite the fact that he's got a different model, right, than mine, we still get the same answer. So the point is, use my model because it's a lot easier. But these are it, right? Foreign stocks, 15.841. International bonds, 52.548. R1, 1895, 698 are 5, 41, 15, 899, and then my expected return was equal to 10. Same thing as your author got. So what is this saying? All right, so if I invest, 15% in foreign stocks, 16% foreign stocks, 53% international bonds, 4% long-term growth, 27% short-term value, right? Then I am expecting to get a return of 10%, and my variance is going to be 27%. Okay. Now again, it's the expected return, right? I don't know what year, what scenario is going to occur, right? So this is, on January 1st, if I invest my money in this way, then I would expect to get a 10% return. Now I want you to see, and my point is, if the year 1 returns occur, I'm going to get like 19%. If the year 2 returns occur, I'm going to get 11, 12%, so on and so forth, right? So this is the expected trend, right? This is on January 1st of the coming year. What do I expect to get at December 31st of that year? I expect to get 10%, okay? Because I don't know what scenario or what state I'm going to be in, all right? Okay, well, there you have it. So this problem was minimize the variance, right, subject to some return. Well, I can flip this around and say minimize my variance subject to, or I'm sorry, I said that wrong. I can flip this around and say, look, I want to maximize my return subject to minimizing my variance, all right? So in this problem, I'm going to get rid of that constraint, and now my constraint comes up here. So here I want a less than or equal to, because I want to minimize my variance. And so I'm just going to say 25, right? I'm only willing to take on a risk of 25%. Okay? Now listen, that's it. Now I am ready to solve this model. That one simple little change allows me to ask that question, to maximize the return subject to minimizing my variance. So let's give it a go. So data solver. Okay, so now I want to maximize the return by changing all of these cells, but subject to, now I need to delete that constraint and then add, I want to keep this one because that's my sum constraint, right? And then I want to add this constraint. So this number has to be less than or equal to this number. Okay? Non-negativity, non-linear, solve. Here you go. So what this is telling me now is, I want to invest my money in this pattern, right? And if I do so, my variance will be 25%. But notice what happens, my return, right? If I want to minimize my variance at 25%, then the most I'm going to be making in expectations is about 9.65%, okay? And then again, the same thing applies. I hope I'm not beating this horse too badly, but this is the expected return, right? This is what you would expect to get on January 1st, right? Again, if the returns from scenario 1 play out, you're actually going to get 18%. If the returns from scenario 2 play out, you're going to get 11%. But on January 1st, you don't know which scenario you're going to be in, right? Hence the reason for the expected returns. You're trying to maximize the expected returns. Okay, well, at any rate, there you go. A very simple Markowitz problem. The reason I don't particularly care for this is, yes, it's true that you're calculating the variance of your portfolio, but this model doesn't take into account the covariance between your various investments. And that's what the next model is going to do. I actually think the next model is a more robust model. And it's probably a model, to be honest with you, it's probably a model that financial planners use. I'd be shocked if they actually used this one. They'd probably use something more akin to what I'm going to show you in the third video. So at any rate, there you go. The Markowitz problem from the book. And remember, you can maximize return while minimizing risk, or minimizing risk subject to some return. All right, there you go. I will see you later.